The last type of probability that we're going to be looking at is called geometric probability. And geometric probability is calculated by looking at the areas of shapes using the length or width or other formulas to calculate area. So here these are called geometric probabilities. And here are some formulas we might need. So area of a rectangle, that is area equals length times width. We have area of a circle, that's pi times the radius squared. And then we have area of a triangle, and the area of a triangle is the base or the length times the width multiplied by 1/2 or divided by 2. So 1/2 times length times width, or length times width divided by 2. It means the same thing. So let's look at some examples down here. So we're going to find the probability that a randomly chosen point in the figure lies in the shaded region. So what we need to do is we need to calculate the area of the shaded region, because remember, probability is the number of success divided by the number of possible. So we want to get the area of shaded region, and we want to divide that by the total area. That will give me the probability that my randomly chosen point will be in that shaded region. So the area of the big rectangle, so I'm going to abbreviate with A, and then big rectangle, that's going to be 15 times 9. Okay, and if I type that into the calculator, that's going to give me 135. So the area of this whole rectangle here is 135. Well, to get the area of the shaded part, I need to subtract this part right here, this smaller rectangle. So area of the small rectangle that's going to be the length 9 times 3, or 27. So then the area of the shaded part or region is going to be 135 minus 27. The whole thing minus the unshaded part, and that gives us 108. So we have now the area of the shaded region, which is 108, divided by the total area, which we calculated was 135. So that's the probability of hitting a point in the shaded region. And if you were to divide that out, that equals 0.8, which is the same thing as 80%. So the actual calculations are not really difficult. We're multiplying. We're finding areas of rectangles or other shapes, and we're subtracting, or in other cases we could be adding to find some areas. There's just a lot of steps to this, and you really have to think about, what am I trying to find and how do I get there? There's no formula for the area of this type of shape, but we can calculate the area of that shape by taking the whole rectangle, the big 15 by 9 rectangle, and subtracting that little one on the inside here. That will give us the shaded region. So let's look at number 2. A dart hits the board. What is the probability that it will hit region 2? So let's find region number 2. That's right here. So I want to know the probability that I'll hit this region. Well, what is the area of region 2? So the area of region 2 is going to be 30 times this right here, which is 15, this length right there. So the area of that is 450. Now we have to figure out the area of the whole shape. Well, this whole distance here is 25. So area of the whole thing is going to be 25 times 40. Because that whole distance will be 10 plus 30. So 25 times 40 will be 1,000. So the probability that I'll hit my shaded, or not my shaded, my region number 2, which is right here, is going to be 450 divided by 1,000, which equals 0.45. Well, 0.45 as a percentage is 45%. So the answer would be A. All right, let's look at number 3. Now this one looks like there's a lot there. Find the probability that a dart thrown at the given target will hit the shaded region. Assume that the dart is equally likely to hit any point on the target. So we need to find the area of this shaded region, which is a circle, but there is a triangle inside that circle that we have to account for and subtract out. So let's start very broad. We know we got to get the area of the whole thing at some point. So the area of the square, you know it's a square because both sides are the same length. So the area of the whole thing, or the area of the square, is going to be 18 times 18. And if we type that in the calculator, we get 324. So we have the area of the whole thing. It's 324. Now let's find the area of the circle. So area of the circle. Remember, the area of a circle we wrote up here was pi times the radius squared. Well, the radius is half the diameter. This segment right here is the diameter, which is the same thing as this side here, 18. So half of that is 9. So the radius of this circle is 9. So area is going to be pi times the radius squared, which is 9. And if we type that into our calculator, we're going to get 254.47. So the area of just the circle is 254.47. The area of the whole square, the whole, target here is 324. Now we need to account for this triangle on the inside. The area of a triangle is 1/2 times the base times the height, or base times height divided by 2. Here is the base of the triangle, which we were just talking about, that it is 18. The height of the triangle is this distance here, which is half of 18, or 9. So the area of this triangle will be 18 times 9 divided by 2. And that gives me 81. So then the area of the shaded region is going to be that circle, 254.47, minus the triangle, which was 81. So if I type that into my calculator, I get 173.47. Okay, so that's the area that we want. That's the shaded region. That is our success. So then the probability is going to be 173.47 over 324. Because 324, remember, is the area of the whole shape, the whole, I guess, dartboard. And we get 0.53, or sorry, 0.54, which is 54%. So again, the math itself wasn't very hard, but you really have to think and say, okay, what are we given? What do we know? And how can I use that information to, add, subtract, multiply, divide to get what I'm asking you to do? So take these problems one step at a time. At minimum, find the area of all the shapes you see, and then we can work on subtracting them to get what we want. All right, now let's look at the last page here. So we have a square, and we have three circles on the inside here. So we're throwing a dart at this board, and we're equally likely to hit any point inside the board. And we're going to find the probabilities. So let's get the area of the whole thing. Area of square. Okay, that is going to be 18 times 18 like we had on the previous page. And I think that was 324. So all of these probabilities here are going to have a denominator of 324 because that's the area of the whole board here. Now we're going to have to find, the area of some of these circles. So the probability of scoring 10 points. We only score 10 points if we get this part right here. So we're going to find the area of the small circle. And we know that each one of these segments is 3 inches. So the radius of that small circle is 3. So we're going to have pi times 3 squared, because remember the area formula for a circle is pi r squared. So you type that in the calculator and we get 28.27. So the probability of getting exactly 10 points would be 28.27 over 324. So we type that in our calculators, and we will get 0.09, which is equal to 9%. Now, letter B says the probability of scoring more than 2 points. Okay, so more than 2 points means I could get 5 or 10 points. So I want the area of this circle right here. Now, the radius of that circle is going to be 3 plus 3, because remember, each one of these segments over here is 3 inches. So that light blue circle has a radius of 6. So the area of the medium circle is pi times 6 squared. And I'm writing it out like this, like I'm finding the area of each of these circles separately, because we might need to use them in a separate problem. Like we may have to go back and use this 28.27 for a different part of the problem. So I get 113.1 to land inside either the 5 or the 10-point area on my dartboard. So the probability is going to be 113.1 over 324. And we get 0.35 or 35%. And like I said, because the whole area of this board is 324, the denominator of all these probabilities is going to be 324. Probability is the success divided by or over the possible. So all of these will have the denominator of this 324. So the probability of not scoring any points. So I want to know what's the probability that I land outside this circle. I want to hit one of these regions here. So we need to find the area of those regions. Well, we need to find the area of this large circle that I outlined in pink. So area of large circle is going to be pi times 9 squared, because again, each one of these segments is 3. So you put it all together, that gives you 9. So pi times the radius squared, the radius again is 9. And we have this calculation up here actually, right here. It's 254.47. So that's the area of the large circle. So the shaded region, so the area of the shaded region is going to be 324 minus 254.47. All right, so 324 minus 254.47, and I get 69.53. So then the probability here is going to be 69.53 over 324. And we get 0.21, which is 21%. So if you were to throw a dart randomly at this board, there's only a 21% chance that you're going to get 0 points. So your probability is pretty good that you'll get something out of this. Now, letter D is a little bit tricky because we want to know the probability of scoring exactly 2 points. So let's erase this. We want to know what's the probability that I get not only inside that circle, but I don't want to land inside the purple one either. I want my dart to land in this, area right here, that looks kind of like a washer. So we have to find that area. Well, if we take that large circle and subtract the medium circle, and you can see I outlined the large circle is in green. That medium circle is in purple right here. If I subtract them, then I should get the area of just that washer. So area of the washer is going to be the large circle, which we calculated was 254.47. We calculated that in letter C, minus the medium circle, which was 113.1. We calculated that in letter B right here. So if you were to subtract those, that's going to give us the area that we're looking for. And that gives me 141.37. So the area of this yellow region up here that's shaded is 141.37. So then the probability of getting exactly 2 points will be 141.37 over 324. And that is 0.44 or 44%. So it's almost a 50% chance of getting just 2 points. Let me zoom out so you can see all of these. So yeah, this problem was more involved because we had to find the area of all these circles and then subtract some things and add some things here and there. So like I said, it's really important that you focus on what you are given and what you're being asked to do. Using these area formulas isn't the hard part. We're multiplying and we're squaring in the radius in the terms or in the circles. But figuring out what to do with that information, that's going to be the tricky part. And that's what we have to practice more with. So, if you need to review some of these, go ahead and review them. Thanks for watching. Make sure to like and subscribe.